Yes, hello students. In this lecture, I will discuss the discontinuous conduction mode. In the previous lecture, we had seen how the machine behaves in the case of continuous conduction, that is, when the current doesn't fall to zero. Now, when the current falls to zero before the beginning of next cycle, then the equations are slightly more complicated. So, you recall the previous lectures where we discussed the waveform in detail. We have seen that when the current falls to zero, the back EMF of the motor appears across the terminals of the motor, and the output voltage becomes equal to the back EMF. So this is the back EMF, which is slightly less than the average value of armature voltage. So this is the back EMF. As soon as current falls to zero, the output voltage becomes equal to VA, becomes equal to E, that is the back EMF. And when we trigger the thyristors, current starts rising again, and the output voltage becomes equal to the source voltage. So output voltage is like this, and in the negative cycle, current still flows. When the current falls to zero at omega t equal to beta, thereafter the output voltage again becomes equal to E. So the cycle completes here. So let us again assume the cycle to be from alpha to pi plus alpha. After that also the cycle repeats. So if you want to find the average value of output voltage in this case, you have to integrate from alpha to pi plus alpha again. So average output voltage in this case will be equal to 1 upon pi alpha to pi plus alpha. During this interval, the voltage is VA d omega t. Now this VA is having different values for different intervals. From alpha to beta, VA is equal to Vm sin omega t. So you have to break this integral into two parts. Alpha to beta, it is Vm sin omega t, and you have to integrate it here. So into d omega t, like this. Plus from beta to pi plus alpha, the value becomes equal to E. So E into d omega t. So integrate it and put the limits, and you will get VA is equal to Vm cos alpha minus cos beta plus pi plus alpha minus beta into E divided by pi. So this is the average value of output voltage in the case of discontinuous conduction. So this is also simple, but here there is one difference here. You know what is alpha, but you don't know what is the value of beta. The instant at which the current falls to zero, this is not known to you. So you have to determine the value of beta if you want to know what is the average output voltage. So for that, you have to write equation for this current, the current that varies during alpha to beta. You have to write the equation for this current. So during this interval, what is the voltage across the motor? It is equal to Vm sin omega t. So you have to write the KVL equation, solve it, and find the equation of Ia in terms of omega t. So for that, during this interval, that is for omega t between alpha and beta, the voltage is equal to Vs, that is Vm sin omega t, and this voltage appears across the motor. The motor here I have shown as RLE load, Ra inductor, the armature resistance, La is the armature inductance, and E is the back EMF. And during this variation in the output voltage, the speed remains practically constant because of high inertia of the motor. So E can be taken as a constant voltage source. So this is the equation, and here the impedance of this circuit is Z, and Z is equal to Ra square plus omega La square root of this. So impedance of this circuit is Z. Now you can draw here the impedance triangle also, Ra omega La. So this is nothing but the impedance of the RL circuit. You can write here from here that omega La upon Ra is cot phi is equal to Ra upon omega La. This will be having significance in this equation. So now the KVL equation, apply Kirchhoff's voltage law here and see what the equation. It is Vm sin omega t, the source voltage, is equal to Ra Ia plus LA di over dt plus the back EMF E. Now this back EMF E you can take on the left hand side and you can write the equation as minus E. So you can say that now there are two sources acting on the RL circuit. One source is certain source Vm sin omega t, other is the DC source having magnitude minus EA. So you have to solve for the current IA. The technique that you can use here is that you can apply the principle of superposition, write the equation for the AC source and DC source and then combine the responses. So for that I have written this equation. The solution corresponding to this will be equal to Vm by Z impedance into sin omega t minus phi. Phi depends on the value of RA and LA. It is nothing but the angle of this impedance triangle. So this is the value of phi. So this is known to you, main inductance and resistance phi is known to you. So this is the first term, that is a steady state solution corresponding to the AC source. Then corresponding to the DC source, the steady state current will be equal to minus EA upon the resistance. So this is the second term, that is corresponding to steady state solution corresponding to the DC source minus EA. And then you will have a transient term also, and that can be written as some constant K e to the power minus t upon tau, that is LA upon RA, that is minus RA t upon LA. This you can write in a slightly different way. I simply multiply here by omega and divide it here by omega. So this is omega t, and you can see that RA upon omega LA is nothing but cot phi. It is convenient to write in this way. So you can write it as, instead of writing like this, you can write this equation in terms of, this is a minus cot phi omega t or minus omega t cot phi. So now this is the equation here. Now in this the constant k is not known, so you have to determine the value of k using some boundary condition, and the boundary condition that is readily known to you is that at omega t equal to alpha the current is equal to 0. So just put omega t equal to alpha and find out Ia alpha. So Vm by Z sin alpha minus phi minus E upon Ra plus k into minus alpha cot phi. Plus of omega t, I put alpha here. So this is the equation, and everything is known to you. You can find out the value of constant k, and this comes out to be E upon Ra minus Vm by Z sin alpha minus phi e to the power alpha cot phi. Alpha cot phi. So this is the value of constant k. You just put the value of k, constant k, in the equation here, and finally determine the equation of the current Ia. So just put the value of k there, and you can write this, obtain this equation. Vm by Z sin omega t minus phi minus sin alpha minus phi e to the power minus omega t minus alpha cot phi minus E upon Ra 1 minus e to the power minus omega t minus alpha into cot phi. So this is the final equation of Ia in terms of omega t and phi and alpha. So now equation is known to you, and if you take any particular problem, the voltage is known, impedance is known, phi is known, alpha is known, Z is known, Ra is known, everything is known, and you can find the value of omega, value of beta, applying the boundary condition that at omega t equal to beta, current again falls to 0. So to find out the value of beta, you just put omega t equal to beta and equate the equation to 0. that is, we have to make Ia beta equal to 0. That is, in this equation, what we will do? Here, you have to write beta cot phi, and again here beta minus alpha cot phi, beta minus alpha cot phi, like this, and just equate this equation to 0. Now here you can see that the only unknown quantity here is beta. So this you can obtain. So this is a non-linear equation. It is not possible to find out the solution of beta in terms of some equation, but you can apply hit and trial method. You know the range of beta, it can be between pi and pi plus alpha. So in this range beta will be there. You just put different value of beta till you get this value equal to 0. So that value of beta you can obtain by hit and trial method. Knowing beta, you can find out what is the average value of output voltage. So in that way you can determine the average value of output voltage. Once you know the average value of output voltage, you can find out, you can apply Kirchhoff's voltage law for average values, and you can find out what is the current flowing in the motor, average current. So if you want, you can find out average value of current that is flowing into the motor as average value of voltage minus E upon RA. So there will be two types of problems. Once in one type of problem, if speed is given, you have to find out what is the torque corresponding to this speed. So if speed is given, you know what is the value of E. You obtain the value of beta and you found the value of VA. So knowing VA and E, you can find out the current. Knowing current, you can find out what is the torque. Or in other type of problem, torque is given, you have to find out the speed. Again, you find out the value of beta. You find out the current corresponding to that torque, and then you find the value of E corresponding to this torque, and corresponding to E you can find out the speed. So there are two types of problem, and these you can solve once you have solved written this equation and obtain the value of beta. So in that way you can approach the problem when the conduction is discontinuous. So that is all for this lecture. In the next lecture we shall try to find out what are the conditions in which the conduction is continuous or discontinuous. Because when the problem, you are getting some problem, you don't know whether the conduction is continuous or it is discontinuous. So what equation you have to use for average value of output voltage? Whether you use this equation or it is simple equation 2Vm by pi, that equation we derived in the last lecture. So you have to ascertain whether the conduction is continuous or it is discontinuous. So how to find it out, how to determine or establish whether the conduction is continuous or discontinuous. So this we shall discuss in the next lecture. So that is all for today. Thank you.